All right, next graph we're going to look at in section 8.2, part 2 is a lemniscate. So if you look at number 5 down here, a lemniscate is a figure 8. Very similar to the infinity sign right here. But look at how my equations look. R squared equals a squared sine 2 theta. This always happens to be a 2 right here. Or r squared equals a squared cosine 2 theta. This is the problem we're going to look at. R squared equals 64 sine 2 theta. So remember, this is squared. So really a here happens to be 8 within my problem. Now what I've already done is I've already written the graph name, which is a lemniscate, and I've got my equation over here as well. R squared equals 64 sine 2 theta. So we're going to go to our calculator. We're going to make sure our table is starting at 0, increment by 15s, and both of those are in auto. When I go to y equals, I'm going to put my new equation in right here. Now, key thing right here is my equation list says r. So in order for me to get my solution, I'm going to have to take the square root of all of this. We're going to type the square root in first. So the square root of 64 sine of 2 theta. Remember, use that X button in order for you to get that. Okay, you got to take the square root first whenever you have a lemniscate. All right, next thing I'm going to do is go to my table and look at my values for each of these rounded to the nearest tenth. All right, so at 0, we've got 0, so that's 0, 0. At 15, we're sitting at 5.7, 1 decimal place right here. At 30, we've got 7.4. At 45, we've got 8. At 60, we've got 7.4. At 75, we've got 5.7. And at 90, we're back to 0. All right, so let's move it to get to 105. Now, if you notice, everything from 105 to 165 has an error in it, which means it does not exist. I'm just going to put some dashes here all the way through 165. But be careful, at 180, we're back to 0. All right, scrolling up now, I'm going to start at that 195. I've got 5.7. You see those same numbers popping back out. 7.4, 8, 7.4, 5.7, and we're back to 0. Now, starting at 285, from 285 all the way to 345, we have an error message again, which means it does not exist. So let's put some dashes all the way through 245, and at 360, we're back to 0. Now, we don't have as much to graph within this problem because we have a lot of errors going on. All right, so let's graph this lemniscate, which is basically going to make us a figure 8. So 0, 0, don't forget we're at the origin right there. At 15, we're going to go out to 5.7. Very close to 6. At 30, we're going to go out to 7.4, which is about right there. At 45, we're at 8, so we're hanging at the very end down there. At 60, now we're back to 7.4, which should match this one right here. And at 75, we're back at 5.7, which should match this one right here. And then at 90, we're back to 0. So you see part of that figure 8 right there. Now the next one we're starting at is 180, 0. So here's 180, 0. 195, we're going out to 5.7. Close to 6 there. At 210, we're at 7.4. And at 225, we're all the way at the end right there, which is that 8. At 240, we're back to that 7.4. And at 255, we're back to that 5.7. And then 270, we're back to 0. Now, if we connect these dots starting at 0, it's really going to look like a rose with 2 petals. But here we have the infinity sign. Same thing as a figure 8. Now, let's look at some examples, creative examples of some lemniscates. So here's an example of a lemniscate. If you look at this, it's the wings of this bee that make the lemniscate in this problem. Same thing right here on this bug. It's the wings that are the lemniscate. Other parts are details. The propeller on this plane is the lemniscate in this particular drawing right here. This right here is an hourglass. So the part on the inside, the hourglass, is the lemniscate on this problem. All right, here's one last example of a lemniscate. It's the mermaid's tail that makes this lemniscate. So we can get very creative here with using these different graphs in order to graph. So a lemniscate is in the shape of a figure 8. It starts off with r squared, so remember when you plug in your calculator, you got to take the square root first.